So thank you so much for introducing us. I'm also, can you hear me, right?
Yes.
Okay, we'll leave that one. So first of all, before my presentation, I would like to say thank you so much for bringing us here today. We are really excited to share about our research experience to our Southeast Asia neighbors. And I'm also from Burma, Myanmar, and then the student said today is the first day of a new year in our country. So I'm originally came from Myanmar. So it's just information. So I came to the NIU in 2021 and during the first week of January. It's very snowy and I have never experienced this much snow. And so NIU treat me a lot warm and then kind heard from the Southeast Asia faculties. So I really appreciate that. So I'm also a Fullbright US ASEAN visiting scholar in 2020. So after Fullbright period, I became the research associate and then I keep working with this water-related project with Dr. Melissa Lanchowski in the Department of Atmosphere and Environment in NIU. So today my talk will focus on microplastic in the freshwater environments. Okay, but that one is everybody already know about that. What are plastics? So we already know that plastics are synthetic or semi-synthetic polymers made of long chains or repeating molecules, singular molecules, and then they combine together and then they became the polymer, right? So these are known for their durability, flexibility, lightweight, and low cost. So we are really happy to use these plastic back, like century ago. But these plastics mainly derive from our natural resources, right? Petroleum and then natural gas. So these habituals across modern society are now present in all our Earth system, including our air, our atmosphere, our water, surface water, groundwater, drinking water, and soil and sediment as well. Okay, this is the pathway of how we produce the plastic, and then they give us the plastic pollution to the environments. So the step one is that people firstly drain and then frack the wine from the ground, and then we do transport the crude wine to the refinery, to the factory, and then we just separate crude wine into the liquid and gases, and then we create these different types of plastic by manipulating polymers and then building changes. So then finally, we produce plastic bottle and a plastic bag and a plastic food container, and then finally we produce these many kinds of plastic into our environment, right? So when did plastic use become widespread? Since 1950, between 1960, so we use in the household item, in the packaging, and also in the automotive industry, people have used these type of plastics since 1950. And after 1960 and around 1970 to 1980, so we started to use the single-use plastic and disposable culture. These culture expand. And from 2000 to until now, we have the global plastic productions include 400 million tons per year. So can you imagine we produce this much amount of plastic pollution per year? So this plastic waste accumulation becomes a major environment and also geochemical issue in our environment. So this is in 1950, and then the lady he was showing that it's easy to use this household item instead of using the stainless steel. That we use the plastic packet is way easier. Just the advertising. So because of this plastic waste, we have the global impact. So this plastic waste is a significant contributor to the marine pollution, with millions of tons entering the oceans annually. So we started to notice about plastic pollution in our oceans first. And 70% of these pollution end up in managed landfill and or incinerated. About 10% is just recycled, and the remaining 20% simply escape into our environment. So the marine pollution in the form of plastic, sewage, chemical, and other byproducts pose a risk to the fisheries and tourism. So you can see in that picture. So in the first picture, that very light dot in the coastal region of most of the Southeast Asian countries. You see the red dot up there. So these are how much plastic polluted in these ocean-related countries. So according to the 2023 data, so we got that information. So highest ocean plastic weight polluters are mostly from Southeast Asia, unfortunately, from the Philippines, and also like my home country, Myanmar, and Indonesia, Malaysia, and that some of the countries, they produce a lot of this plastic into the ocean. So today I would like to focus on microplastic, right? So we know that plastic, but for a long period of time, this plastic gave us the microplastic, teeny tiny particles that we can't evenly see with our naked eye, right? We use the microscope to see these microplastic. So the microplastic are the plastic pieces of the fiber that are smaller than 5 millimeter in size. So microplastic and the environments are becoming a greater concern as we scientists and researchers started to begin to understand their penetration into our ecosystem and also the food chain. So scientists already detected the microplastic in our human organ already. So microplastic found in the human brain, blood, and human organ as well. And generally, we could say 2 types of the microplastic: primary microplastic and secondary microplastic. So primary microplastic, these tiny pellets are melted and used to create larger plastic items. In fact, most common plastic items are made from these pellets, from the water bottles to like some kind of holiday decorations. Another example are microbeads. The microbeads that may be found in our personal care products such as toothpaste, our face wash, and also the cosmetic. The primary microplastic are like tiny particles designed for the commercial use. And then secondary microplastic come from these larger plastic such as beverage bottles, bags, and twines. But after a period of time, so we see sand, heat, wind, and wave can cause these plastic to become brittle and break into the smaller and smaller pieces that may never fully go away. The secondary microplastic also came from places that we have never expected, like microfibers such as from our like clothing and textile, and also like fishing nets. So when we look at the size comparison, like for the microplastic side, we can see with our eye, okay, this is macroplastic. But the microplastic side in between 1 nanometer to 5 millimeter is really hard to see with your eye. And if the size goes down to nanoplastic side, we will need more advanced technology to see these nanoplastic sites. So even those can be in your food or your water bottle, or so anywhere, any things you are belonging to. Some of the research are still ongoing, but we don't know yet what will be the problem if microplastic in our body. But the research are still going, and it can impact to like for a long period of time. It can impact to our lungs or liver or diarrhea. But the research are still ongoing. So what do microplastic look like? For example, microplastic can be in different shapes. So there are 3 like major shapes. So microplastic mostly come in like sphere, cycle, and fragment, and then fiber. So mostly these shape. And for example, if in our normal day we use like these food container, right? So when I check this food container with the like laser technology, we see this fold under this microscope. So together with microplastic, we also notice that tire wear particle, which is really problems nowadays. So scientists are tracking these tire wear particles as well. So we didn't notice that when we test the microplastic in our environment, water sample, for example, we found lots of rubber together with these polymers. So we were surprised that where are they coming from? And then we track, and then we just get in the science like microplastic like section in the AGU conference last year, and then we sit down and then we discuss, okay, what is the major source of this tire particle? Because these are from tire, and then they come together with this polymer and then go into our waterway. So the tire are a major source of microplastic, and they can spread into the air, water, and soil. Like same thing with the microplastic. Just in the USA alone in 2022, there are 338 million tires sold out. So because these particles are also non-biodegradable and persistent in our environment. So they are the common polymer types. If you are at the chemistry background, you already know that for the other people. In the microplastic, we have the common polymer types like polyethylene. So polyethylene and polypropylene and PET. This first one, PE and PET, are mainly used in your plastic water bottles. So I brought that one. So they mainly made with this PE and PET polymer. And polypropylene is mostly used in your food container, food packaging, and polyamide nylon is, you know that nylon. So sometimes we buy the clothing, so we always check at the back the 100% cotton or how many percent of polyester, like you can check. And PVC, you know PVC, right? So almost our house we use PVC pipe, we do water drilling, so we do pumping, we use the PVC pipe. And why this polymer type matters? Because these polymer can travel all the way like water system, also even stay in the air. When we breathe, these nano types of plastic particles can go into our land. Because my talk, well, today I will talk focus on fresh water, so let me back to the water. So according to the data, so in our world, nearly 100,000 rivers are accountable for nearly 80% of global annual plastic emission into the ocean. But when we think about this plastic come to the ocean, where do they originate, right? So they are originating from our freshwater ecosystem, right? The freshwater ecosystem serves as the primary receptacle for various these pollutants released within our watershed. So amount of plastic waste entering aquatic ecosystem could nearly increase from 9 to 14 million tons per year in 2016 to in 2040, so maybe approximately 23 to 37 million tons per year. It's very scary. So microplastic in freshwater system. So we found lots of microplastic in our river and streams and Great Lakes, reservoir, and also my major focus is the groundwater, because I'm really interested in groundwater. The surface water is that we can see, right, on the surface, but the groundwater is very interesting. Groundwater is invisible, right? So we don't know how the contaminant, how do they move or how do they transport. And why the freshwater research is still limited compared to oceans. So many research have already published about the microplastic pollution in this ocean and where the GPDB, yes, so many research already published. But the freshwater ecosystem, microplastic contamination is still like ongoing, like we do. So we do a lot of the water quality monitoring in the Southeast Asia and also the Midwest in the US and also in the Mexico as well. So I found like major river in the US, in the Delaware, Mississippi, Columbia River, Los Angeles River, they already published about the microplastic, how much pollutant. So they brought a lot of the microplastic together with them and they're going into the ocean. So if after our talk, and then if you are interested about this one, so I will skip this slide. This is about the US EPA. They released this application, and then you can track how many microplastic and how many plastic trash in the river. So when you go to this link, and then you can check your nearest rivers or how many plastic they carry. So why we talk a lot about microplastic? Because microplastics are everywhere, from the South Pole to North Pole, and then also all the way tops of mountain and also groundwater as well. So it is very important to discuss in our SDGs, Sustainable Development Goals. So microplastic pollution is heavily related to SDG goal number 14. This is about life below the water, because our ecosystem like fish, shrimp. So if they eat this microplastic, and then we just eat this kind of fish, and then microplastic can circulate in our living organism, right? And one of the projects I have done we do the water quality monitoring in the northern part of Illinois, which is pretty close to the Wisconsin. And we do water quality monitoring in the Kishwaukee River. So firstly, we do like water quality monitor. We just test only like how much pH, how much water temperature, and the nutrient. But after microplastic research come out, so I started to track the microplastic pollution through this watershed, the Kishwaukee River. So I just separate the rural area, urban area, and the residential. So I spray and I track how much microplastic concentration in these different areas. So they are my students, and then they try to collect the water from the Kishwaukee River from the bridge. So we use the water sampler. We just drop down to the water, and then we just grab from top of it. In some areas, for the microplastic testing, we just use the stainless steel stick and then use the glass bottle, and then the student, they collect the water. So this is our MIU campus. And for the microplastic analysis, we do the sample preparation. So it is not, before the analysis, so I thought that, it's going to be easy, we just collect the water and then just test in the instrument. No, it is not, because we do the sample preparation. And also another challenging point is that we do not have the standardized protocol, standardized method until now. So around the world, we do our own methods. So for example, US, we have our own methods, and UK, they have their own methods. So that's why we try to collaborate with different universities. Also, we try to reach out to the British Geological Survey group and hey, what is your method? And then we share our protocol each other. But generally for the water sample, we do these major steps. So we do filtration, so we filter out all larger particles, and then we just do like density digestion, and then we do density separation, and then finally we just collect all the microplastic on very tiny filter. So after collecting our microplastic on the filter, so we have to use what kind of instrument we are going to use. So in the different university, we use different instruments. In my university, we use the LDIR, which is recently released in 2018, and this is very advanced one. So we use the HLN laser direct infrared chemical imaging system. This is an automatic approach. When you see there, when you put the gold filter in the instrument just automatically runs, so how many particles on your gold filter, and then you can track, okay, this is what polymer types like that. So that instrument will give you what types of plastic and its shape, and then it will give you spectrum as well. And also it's like saving your time as well. It just takes about 6 to 8 minutes per sample. So one of my projects about the Kishwaukee River. So here is my finding. So I do this size, and then some of you see that these very high microplastic concentration. These are very close to the urban area. So that give us the information about how much people we just give this waste into our river system, right? And also I check the microplastic shape as well. So what types of shape are abundant in our environment? So according to my research, we found lots of fragments in our water environments. And also I checked this one with the British Geological Survey in the UK, and then they also found that many fragments in their water system as well. So after LDIR, so it will give you this beautiful picture. You see these color here, the fragment and fiber, they all are microplastic. It's very beautiful when you can zoom in, and then you can just extract all the picture as well. Another my small project is we do the microplastic testing in Mexico as well. So in Mexico, you might know about the cenote. Cenote is the natural sinkholes. So we collect the water sample from the sinkhole, and then we track how much microplastic pollutant in the water. And we found lots of microplastic in the sinkhole, and also we tried their drinking water well. They thought that before that they argued, okay, it should not be no microplastic in their drinking water well, but when we test, we found like that median amount of microplastic in their system as well. Now they are tracking back their filtration system now. So is it just advertising? This is our NIU Microplastic Laboratories. We have that page. If you are interested, and you can go into our page, and also you can reach out to me. You will see my email address as well. This is our NIU Microplastic Lab PIs and co-PIs. So here's the Melissa Lanchowski. She's the professor, and then she's leading this project, and Dr. Megan Brown. So they just lead the projects, and then also I just ran the whole lab, and then I maintain the lab, and then I also develop the method, and also like QA, QC, quality control, and quality assurance. So we three are like working together this project since 2024. We got the grant from NSF, National Science Foundation, to buy this laser LDIR technology in early 2024. Starting from early 2024, we just diving into this microplastic research. Yeah, thank you for this is all my presentation. If you have any question, we can do Q&A after Dr. Bao-Son talk.
Good afternoon. So thank you for Mary. Thank you, Mary, for inviting me here to give a talk at the University of Wisconsin-Madison. So thank you, Dr. Chit. So very interesting information. So following Dr. Chit's presentation, I'd like to present my study about microplastics in aquatic environment, the sources, where it comes from, and how the impact to the to the aquatic organism, particularly the local organism in the case study in my country. Yes, sir. It's short my biography. My name is Bao-Son Trinh, and I work for the University Institute for Development Study, and I have more than 10 years working with the Vietnam National University. So let me very briefly talk about the source of microplastics in my research. So as Dr. Chit already introduced you, the plastics, it comes from the petroleum products, and then from petroleum product they make the plastic product for daily use, for long-term use, and the question is where the plastic, where do they go? So after use, the plastic product mostly can go to the recycling facility, and the remaining go to the landfill, go to the incinerator, but a large amount still go dumps directly into the river, into the aquatic system, particularly in the development country like in Southeast Asia country. The report say that there are more than 50%, some countries, some areas, there are more than 50% of the plastic waste dumped directly into the aquatic environments, particularly in the river system. So when the plastic waste go to the environment, what will happen? So the first, when the large plastic, we call that the macroplastic, larger than 5 millimeters, will be broken into smaller one. And first, the aquatic organism misunderstand, think the small particle is their food, and they can ingest in their body, because that is very tiny, small, tiny particle. So the low trophic organism can eat it, and then the high trophic organism can eat the small one, and following the food web, it can transfer into the higher trophic organism, like from the zooplankton to fish to bird, and maybe to higher like the mammal animal, and finally it can come into the human body. So the first impact of microplastics is ingestion. So the second one also very important, and some people will not easy to see that the plastic can associate with other pollutants in the river system. For example, the plastic can absorb like the persistent organic pollutant like such as pesticides, such as some PFAS, PCB, that is very toxic pollutant. And also it can associate with pathogen or heavy metal, and in that case, microplastic can be a vector, can transform all the pollutant into the body of the destination body. So there are two impacts of plastic or microplastic. One is ingestion, the second one is association with other pollutants. So here is some example of my research. I found out there one fiber in the ingestion system of a fish with the very the low trophic organism like Daphnia magna, and we found that here is the small green particle, here is the microplastics inside the stomach of the Daphnia magna in the stream. We can see this microplastic also in the head, in the stomach of the stream. Let me come to my case study. So my case study in Vietnam, and here in Vietnam in the Southeast Asia, in the North is China, in the South like Indonesia, and Vietnam we have very long coastal lines, about more than 4,000 kilometers to the Pacific Ocean here. So most of the microplastics in the river system will flow to the Pacific Ocean. And my case study focused on in the south of Vietnam. So here is the watershed of the Sai Gon river system. So my study focused on this area. And I sample from the upstream of the Sai Gon river to the downstream, and Dong Nai River from the upstream to downstream, and particularly two river systems flow through the very crowded, very high density population of the city. Here in the Ho Chi Minh City or the Vietnamese Sai Gon, with more than 10 million people, very high density population. And here with the Dong Nai River system, it flows to many industrial parks. There are a lot of factories along this river, and before it flows to the Pacific Ocean here. The sample I collected is two types. The first type is plastic debris, including macroplastics, which one is larger than 5 millimeters, and microplastic, which one is from 0.3 to 5 millimeters. And the second type of sample I collected is aquatic organisms, including zooplankton, fish, large benthic, invertebrates. And here is the method for collect microplastics. Here I use the catamaran with the net, in the middle, and we tow along the river from F time and block time. And here the microjaw to collect the small particle of microplastics. And I also collect the microplastic at the bed of the river. Here is the real instrument I use in my lab. This one for collect macroplastic inside it, and this one for microplastics. And here the method for collect the aquatic organism. This is the method for separate macroplastics, and we can see a lot of everything in here, and then we separate from the microplastic to the organic waste. Then finally we got the microplastic larger than 5 millimeter. And this is the method for separate small particles of plastics. And here this is the real picture of the microplastic from the microscope. With the river sediment, we use this procedure to separate plastic from the sediment, and we have the instrument we call that the microplastic sediment separator. And with this one, we can separate the plastic in the sediment from the river, from the riverbed. And here the procedure how we can count the microplastic injected in the body of the aquatic organism, including it is zooplankton, fish, or large benthic invertebrates. And what did we find? So first we talk about the macroplastic in surface water of Sai Gon River. And we found that most of the plastics, the macroplastic, is polyethylene, polypropylene, or polystyrene. It is some most of popular plastics we found in Sai Gon River. And here this result interesting, very interesting. Here is the plastic way not in the upstream of the river, of course, because upstream of the river after the hydropower dam, so it have not much plastic waste. So the upstream very low, but in the downstream also very low. And in the middle, where a lot of the people, where the high density of population, the people live. So we found out a lot of plastic waste in the middle of the river, where a high density of the population. And that is one reason. And one more reason we can use for explanation is because in this river system, it has two types of the water flow. So the block time, that means the water flow from the ocean to upstream, it increases the water level. And then the F time, that means the water flow from the upstream to the downstream. So in one day, in the south of Vietnam, have two types. So for example, now in the morning, the water go up, and then in the afternoon the water go down, and at night the water go up and down again. So one day have two times, and that means the water go up, down, and that cause some of plastic cannot go directly from the upstream to the downstream, but sometimes it go forward and backward and forward and backward. It's very long time. And similarly, we also found some popular plastics in the sediment sample. With the microplastic in surface water, rather similar with the macroplastic, but we found that most of them are polyethylene, polypropylene, or polystyrene. And also similar to the macroplastic, also we found the microplastic in the middle of the river rather than in the upstream or in the downstream. Here is some result from microplastic in sediment. This is the picture, the real picture of microplastic, and we can see that like upstream, the sample here is like less microplastic than here in the downstream. We have more particles than in the upstream. And now we go to some ingestion of microplastic in the body of organism. So it is interactively with we observe in the zooplankton. Zooplankton, that is very small animal, small aquatic animal in the river. And we found that in about 100 individuals, we found about up to four items or 4 particles inside the body. In some other side, we found just 1%. Just 100 of the organism, we found one have 1 particle in their body. It's not too high, right? Here's the real picture of what we found from our study. But very interestingly, we found that absolutely different microplastic observed in the body of fish, that means larger organism. And we found that in 35 fish, we found up to about 30 items of microplastic in the body, particularly with some big fish, with about the fish 2.3 kilogram, less than 1 kilogram, like a big fish. We found that up to 173 particles in just 10 fish like this one. So that means the big organism can eat more, can ingest more, or maybe accumulate more small particle of plastic in their body. We are not sure that it directly ingest, or maybe it accumulates for a long time. Maybe it's from this organism, and then it accumulates for tomorrow, and then one more, and then finally there, on life, it accumulates very high concentration of microplastics. Here in the wave picture, we found in the body of one fish, and here the fiber. With the big fish, you see that in the body of the fish here. One other thing, the impact of microplastic in the environment is the association capacity with all the pollutants. And we analyze the plastic debris with the persistent organic pollutant. And we found that some sample, just only some, have absorbed with the deep compound, very toxic compound, the polychloride between it. And here, the final concentration here is associated with the microplastic. And in this sample, we don't see the DDT one type of the pesticide in the sample. And in the laboratory test, we also test with polyethylene macroplastic absorbed with PCB 101 and PCB 153. And we found that after a few absorption days, like 7 days and 14 days, we found the concentration of this compound or plastic increase. Other thing is that it can associate with pathogen. For example, the E. coli, coliform, and Vibrio. And we found that this information, some samples were absorbed the pathogen on the plastic piece. If we go further, we investigate further microplastic, how they affect on the local aquatic organism. So we know that microplastics are ubiquitous in the aquatic environment. They can be ingested and accumulated by a wide range of aquatic species, from low trophic to high trophic. Low trophic to high trophic here. And I did in total 4 sets of experiments. The first one, I exposed very small polyethylene microbial with zooplankton we call the Moina Microscopic. And the second one, I did the experiment of the microbial associated with the PCB 153, one type of toxic organic persistent pollutant, with the zooplankton Daphnia magna. And then similar, we exposed the similar microbial with the gong, the giant river gong, we call that macroplastics, pervasive. And then the last experiment I did, the exposure of microbial with the hard and both of the organism is very popular in my country, in the river system of where I did my study. So the experiment I used in the laboratory, the fluorescent green polyethylene microbial here. This is bought from Cosperry, and we mixed with the polychlorinate biphenyl 153. Then we expose with the organism here for the experiment for exposure for this experiment very simple. I expose for 24 hours and 48 hours. And then after that, we found after 24 hours, we found there one bit here, and 48 hours also have some signal of the microbial inside the body of the organism. Here the cumulative microbial in the body with the exposure type. Even though very high variation of the result, but at least we can see the high concentration of microbial exposure, like higher than low concentration. And it also affects on the reproduction of the organism. So without like the control here, the reproduction is high, but with the exposure, and we see that it will affect on the reproduction of the organism. The second experiment I did with Daphnia magna, and I did experiment the exposure time from 1 day to 21 days. That's a longer time exposure. And what did we found? We found some particles inside the body of the organism here. After just 1 day exposure. And particularly, this result show that the small particle strongly affect to the mortality of the organism. And we can see this is microplastic exposure group, and this is the control group. And we can see the control group very low, likely than no the mortality after 21 days. But if the organism exposed with the microplastics, and then we can see the mortality increase. And in some sets of experiment, it's up to 100% of mortality. That means after 21 day exposure, 100% of the organism will die. And about the cumulative neonates per living adult. So this is the number of neonates, and this is the number of neonates per the living adult. And this is the group of this is the control group, and this is the exposure with the microplastic group, and it is significant different. So with the control group, the number of neonates is very high, but with the exposure group, the neonates, the baby one, are very low, and this confirms that the microplastic affect on the reproduction of the organism. Similar, this with the experiment exposure this microplastics with the giant river prawn. This is very popular in the Sai Gon river system. And this experiment for long from 0.5 to 28 days. So in each sample we have only one individual of prawn. And we have 5 replication. And we can see that the prawn at first, it is a lot of the microplastics inside, a number of the polyethylene microplastics in the body. So just only 0.5, just a half of day, and we see that. And here not only in this is the ingestion system, and this is like the gills outside. It is the gills of the prawn, and you can find both here and here. And with the prawn, it is very interesting result found that at the first a half of day, and the prawn think maybe they talk the microplastic were their food, and they eat a lot. But after that, after 1 day, 2 days or longer, and they know that's not good for their body, and they have the mechanism to vomit, to put it out of the body properly. This is just assumption. Not we cannot conclude, because we need more experiment to confirm. But at least we saw and we reported what we did. This is different with the mixture between the microplastic and the persistent organic pollutant. And the last experiment we did with the microbes with white hard clamp, and this is very popular in the study area as well. And in this experiment, we did 2 individuals in one beaker, and we have 3 replicates. The time also similar from 0.5 days to 28 days. And we also found a lot of microbes in the ingestion system of the organism just after a half of day. You see this picture? Because the fluorescence of we easy to see under the light, under the fluorescent light. And also similar to from in the beginning period of exposure time from 0.5 that almost just one more slide. No, I mean this because this. And similar with the prong, the clamp also at the fourth period when it exposed with the microplastic and it think it took their food and it eat a lot. It takes a lot in their body, and after one day, and they have the mechanism to put it out again. So that is very interesting finding that we found from our study. And that is all of my experiment. Thank you again for listening.
We have time for questions. We have a question.